here this is 0, 4, let me write it 0, 0, and here it is 4. Let me take any number we can take. This is known as principal diagonal or main diagonal or leading diagonal. Okay, the elements lying in the principal diagonal AII, that is A11, A22, A33, A44, A55, etc. ANN. Okay, so the leading diagonals, okay, elements lying in the leading principal diagonal, or so the elements 2, 3, and 4 are lying in the principal diagonal, and they are non-zeros. We have seen here, and others are zeros. Non-diagonal are lying in the principal diagonal and are non-zeros and are not equal to 0 and are non-zeros. Let me write here. This is known as what is a square matrix. It is 3 by 3 order, of order 3 by 3. So square matrix it is. So a square matrix in which leading diagonal elements are non-zeros, others are zeros. Okay, so this is, we have defined here Aij equal to 0 or I is not equal to j. That means this is A21 0, A12 0, A13 0, where 1 is not equal to 3. So I mean, when I is not equal to j is equal to 0 and diagonal elements are lying are there. So this is known as diagonal is matrix. So diagonal matrix is this. Okay, so it has been defined now, diagonal matrix. Now what is the scalar matrix here? Let me define that scalar matrix now. The scalar matrix is a diagonal matrix type. Okay, a diagonal matrix. The scalar matrix is a matrix, a diagonal matrix in which the elements lying in the principal diagonal are equal. Okay, so they are known as, that is known as scalar matrix. What is scalar matrix? Type scalar matrix now. What is the scalar matrix? A diagonal matrix. Here a diagonal matrix is involved. So a diagonal matrix in which the elements lying in the principal diagonal, or principal diagonal elements, we could say principal diagonal elements are equal. They are non-zero. This is understood because this is diagonal matrix. In diagonal matrix, principal diagonal matrix diagonal elements are non-zeros. That is understood. A diagonal matrix in which principal diagonal elements are non-zeros, understood. But these diagonal elements are equal. When they are equal, that is known as scalar matrix. Lying in the principal diagonal. Okay, the elements in which the elements lying in the principal diagonal elements are equal. Okay, are equal. That is known as a scalar matrix. Or we would say here Aij equal to 0, where I is not equal to j. All elements, non-diagonal elements are zeros, and Aii, or let me take Aij equal to, let me take K constant or C, where or when I equal to j, or let me write here, for I equal to j. For all I equal to j, Aij equal to k. This is second condition. This is second and definition. This is first. Aij equal to 0 in diagonal matrix in which I not equal to j, for that aij equal to 0 and aij equal to k for I equal to j. That means when the principal diagonal elements are equal to k or c constant, we could say c here, constant. Okay, the first letter of constant it could be. This constant is not equal to 0 here. Where c equal to k, where k is not equal to 0 and k is not equal to 0. K must not be equal to 0. K is some scalar quantity. Okay, and they are equal. All elements are equal. So let me write here. If I take a, okay, this is 3 here, 0, 0, 0, 3, 0, 0, 0, 3. We have 3, k equal to 3. It's 3 by 3 of 3 by 3 order, square matrix it is. Diagonal matrix is a square matrix, undoubtedly. So scalar matrix is also a square matrix. Scalar matrix is also a square matrix because it's a diagonal matrix. This scalar matrix or diagonal matrix in which the elements lying in the principal diagonal are equal. That is known as a scalar matrix. These diagonal elements are, principal diagonal elements are equal. 3, 3, it will be 2, 2, any number. Okay, so it means identity matrix, which is next one, I think, identity matrix here. The identity matrix will have here either 1, 1. It is 1, 1 here. In case of identity matrix, there is a diagonal matrix in which this leading diagonal elements are 1 and non-diagonal elements are zeros. That is known as unity matrix or identity matrix. Let me talk about identity matrix. So this is 3 by 3 of 3 by 3 order scalar matrix. It is a scalar matrix. It is a scalar matrix. Scalar matrix of order 3 by 3 of order 3 by 3 of order 3 by 3. We write it like this, 3 into 3, but read as 3 by 3. So of order 3 by 3. Now let me talk about next, which is scalar matrix. Now what is identity matrix? Identity or unit matrix. Identity or unit matrix. Next, sixth one. Now sixth one is identity or unit matrix. Okay. Sixth one is identity or unit matrix. Identity matrix or unit matrix, we could say. So here we could say it may be a scalar matrix or a diagonal matrix. It may be a scalar matrix or diagonal matrix. So a square matrix. Here let me take a square matrix. If we take A is equal to Aij of order m by n, this is of order n by n, let me take. So this is a square matrix where when I is not or Aij equal to 0, let me take here Aij equal to 0 for I is not equal to j and Aij equal to 1 for I equal to j. What does it mean? It means I equal to 1 for I equal to j. We could write here Ai. Is it Ai? Means leading diagonal elements are 1. This is equal to 1 here. It is known as identity matrix. So identity matrix or unit matrix is a matrix, a square matrix. A is equal to this when Ai is equal to 0 is known as identity and identity matrix or a unit matrix or a unit matrix in which leading diagonal elements are equal to 1, are equal and equal to 1, are equal to 1. That means I equal to 1, where I equal to j, or I equal to j. So let me take some numerical examples here. A11, this is 1 0 0. Okay, here it is 0 1 0 0 0 1. This is 3 by 3 order identity matrix, unit matrix or identity matrix. This is identity matrix or unit matrix. This is identity matrix. Okay, of order 3 by 3. So let me take B is equal to, or we could write here 0 0 and so on. This is A11, but this is 1 here. Okay, so we write here 1 0. Okay, and this is 0 1 of 2 by 2 order. This is identity matrix or unit matrix. In this way, identity or unit matrix is a matrix in which leading diagonal elements are 1, others non-diagonal elements are 0. That is in case of diagonal matrix also, in case of scalar matrix also 0. These non-diagonal elements are zeros in a square matrix, sorry, in a diagonal matrix, in a scalar matrix, and in an identity matrix, non-diagonal elements are zeros, and this leading diagonal elements are in this case 1 1. But in case of a scalar matrix, these are equal. This is also a scalar matrix. Identity matrix is a scalar matrix also, but these are equal, but equal to 1. And a scalar matrix can also be represented as, suppose it was 2 here, 2 could be taken common, 2 into I is equal to scalar matrix. So scalar matrix is also involved in, in identity matrix, and identity matrix is involved in the scalar matrix. But in case of diagonal elements, diagonal matrix, non-diagonal elements are not equal, but they are not equal to 0. Okay, they are not equal to 0. Diagonal elements or principal diagonal elements or leading diagonal elements are non-zeros in case of diagonal matrix. This is diagonal matrix, scalar matrix, and identity matrix. They are defined on square matrices. That is first condition, that they must be square matrices. Okay, so this is identity or unit matrix. Now let me talk about the next point. 7th type here of matrices. We are talking about matrices, and the application I have talked about for case of management students. It is very applicable for management students, because in case of management techniques or mathematical techniques or mathematical analysis, the managers require some solutions of simultaneous equation, some simultaneous problems. Okay, those problems are defined in equation form, linear equation form, and those simultaneous equations or linear equations can be solved with the help of matrix algebra. Okay, so matrix or use of matrices, the application for managers is very important for science students, for higher mathematical students. It's very important because it is used in case of astronomy, in case of nuclear physics, in case of aerodynamics, in case of mechanics, in case of algebra, differential equations, etc. So use of matrix algebra or matrix is very important in case of higher mathematics students. In case of management, it's very useful in case of solving the problems. Okay, finding decision making. In case of decision making, managers require matrix algebra. Okay, so this is important for them. Now come to the next point. 7th type null matrix. Okay. Now 7th is null matrix. Null matrix, or known as zero matrix, or it is also known as zero matrix. Zero matrix, null matrix or zero matrix, or matrix A equal to Aij. Let me take A is equal to Aij of M by N, in which Aij equal to 0. for I is not equal to j and I equal to j also, and I equal to j. Aij equal to 0 for I equal for all I equal to j or I is not equal to j. For I equal to j and for all I equal to j, I is not equal to j. These two conditions are there, and for I equal to j also. That means all the elements are 0. We can say that a matrix in which all the elements are zeros, okay, in which Aij equal to 0, or a matrix A equal to Aij in which Aij is 0, or we can define, or in other words, or in simple words, in other words, a matrix in which all the elements are zeros, okay. So zero matrix or null matrix it is known as. It doesn't have any element but zeros. Zeros are the elements of this. If I represent this as 0 0 0 0 0 0, it is 2 by 3 matrix but of 0 order. I mean 0 elements, not 0 order but 0 elements. All the elements are 0. It is a null matrix or 0 matrix, okay. Null matrix and 0 matrix is a matrix. It may not be a square matrix. Doesn't require, I mean square, it being a square matrix is not a prior condition, but a square matrix can be a null matrix also, but it may or may not be a square matrix. So in case of null matrix or 0 matrix, prior condition is not a square matrix. Square matrix is not the precondition of this, okay, or first condition of this. It may be a square matrix or may not be, okay. So a matrix in which all the elements are zeros is known as a square matrix. So this is a 2 by 3 matrix but a 0 matrix, or null matrix. It may be a square matrix also. It is of 2 by 2 order square matrix but 0 0. It is a null matrix. So square matrix may be a null matrix, or non-square matrix is also a null matrix. So it is a null matrix here because all the elements are zeros. So if you have a matrix which is having its elements zeros, or zeros are only elements of it, then it is a square matrix. Now let me take the 8th one, upper triangular matrix. What is the upper triangular matrix? Very important one. Let me talk about that. What is the upper triangular matrix? Now in case of upper triangular matrix, okay, this is 8th one, upper triangular matrix. Upper triangular matrix. Now simple logic that a matrix is square matrix in this case. A square matrix in which the upper portion, the leading diagonal elements as well as the other elements which are okay above the diagonal elements are non-zeros. They are forming an upper triangle. Okay, that is an upper triangular matrix. Let me first define. So if a matrix, if a square matrix here, I'm sorry, it is if a square matrix, let us again write it down. If a square matrix, so if a square matrix in which the leading diagonal or the principal diagonal, the leading diagonal elements and the elements lying above it are non-zeros. Or we can say if A is equal to Aij, okay, of order n by n is a square matrix here, where Aij is not equal to 0 for all I greater than j. Try to understand. For all I greater than j. That means I must be greater than j. For then, let me just write it down that how it is. So A, if I take, this is 1, 2, 3. Now this is 0 here. This is, let me take 4 here. This is 3, or it may be minus 1. Let me take, no problem. 0, 0, and this is 4 here. Again 4. So any number can be taken here. Let me take here 2 here, doesn't matter. So 1, 2, 3, 4, minus 1 and 2. This is forming a triangle, above triangle. So this is upper triangular matrix, in which the elements more than I, this is of 3 by 3 order, square matrix it is. So I square matrix in which for I greater than j, or I is greater than j here. That means I is here representing number of rows. Number of rows is this 2 is greater than Aij is not equal to 0. Sorry, this is Aij equal to is not equal to 0 for I greater than j. It means here I is second row and second, this is first column. Here I greater than 0 is equal to 0 or not. For all I greater than 0, Aij equal to 0 for all I greater than j. That means here I is not equal to, but for all I greater than j, it is equal to 0 here. For Aij equal to 0 for all I greater than j. It means here I is 3, third row, and j is 1. I is 2 here, sorry, 3 here. I means number of row. Row is third, but column is 2. It is I greater than 2. That means I greater than j. So Aij equal to 0 for all I greater than j. This is important point here. Okay, so this 2, second row, first column. Here 2 is greater than 1, is not 0. Here 1, 1 is also there. For diagonal elements are, leading diagonal elements are also non-zeros. Here A1, 1. But this is the condition. Ai is equal to 0 for all I greater than j, not equal to j. We are talking about. This is not equal to, but I greater than j. For that, this value is 0. This is 0 here. For all I greater than j. Here, number of row is 2, column is 1, 0. Here it is 2, 2 is also not 0. Here they are equal, but for not greater than 2. This is 3 and this is 3 again, and 2 number of column is 1 here, they are 0. So for all I greater than j, it is 0. Okay, for Aij, Ai equal to Aij, in which Aij equal to 0 for all I greater than j. Then it is an upper triangular matrix. It is an upper triangular matrix. Important point here. Upper triangular. This is upper triangular matrix. Okay. So in this case, this we have to understand. I greater than, for all I greater than j, Aij equal to 0. This element will be 0 for all I greater than j. It means this 0, 0, 0. The upper triangle is forming. So upper triangle, a triangle is formed in the upper portion of this matrix. This is known as upper triangular matrix. Simple point. Then what is the lower triangular matrix? Next topic is, so upper triangular matrix defined like this. If a square matrix in which the leading diagonal elements and the elements lying above it. This is simple definition, general definition. And symbolically, if I define, then A equal to Aij, A equal to Aij of order n by n. This is square matrix, it must be. Okay, square matrix in which for aij equal to 0 for all this is for all symbolically I greater than j. For I greater than j, aij equal to 0. This is upper triangular matrix here. Now let me take lower triangular matrix. Now in this case, aij equal to 0 for all I less than j. Ninth one is lower triangular matrix. This is the ninth one. Lower triangular matrix. This is known as lower triangular matrix now. So a matrix in which the diagonal elements and the elements lying below it are or is known as below it are non-zeros, are to talk about still elements. So the matrix in which the diagonal elements and the elements lying below it are non-zeros. That is symbolically if I write symbolically or in a symbol form, A is equal to, let me take Aij of order n by n, again I have taken, where Aij equal to 0 for all I less than j. Try to understand. For I less than j, it is 0. Aij equal to 0 for all. So let me write or represent the matrix here, in which, let me take here 3. Okay, this is 0 here, 0 here, 3 by 3 again I am taking. So this is 1, 2, 0, 4, let me take 3, and this is 0 again. Sorry, this is not 0. 4, 3, let me take 5 here. So here the upper elements are 0. Now lower portion is making a triangle. This is a right angle triangle. It is formed. So this is 3 by 3 order. So here this is what? Number of row here 1. Column is 2. So 2 is greater than 1. It means I is less than j. Number of column is greater than number of row. This is 0. Aij equal to 0 for all I less than j. This is also 1 and 3. 3 is greater than 1. First row, third column, 3 is greater than 1. This is 0. Here also. Why this is 0? 2 and 3. Is 2 and 3. Third column and second row. So 2 is less than 3. So this is 0. All Aij equal to 0 for all I less than j. Then it is a lower triangular matrix. So lower triangle is formed. Triangle in the lower portion of this matrix is formed. Because of that, it's known as lower triangular matrix. It is a lower triangular matrix. Lower triangular matrix. It is a lower triangular matrix. Okay. A portion in the lower portion of this or lower triangle is formed. In case of below the diagonal matrix, and diagonal elements also included. Diagonal elements and below this are not zeros. They are non-zeros. Symbolically, A equal to Aij, where Aij equal to 0 for all I less than j. This is the lower triangular matrix. Okay, so lower triangular matrix and upper triangular matrix we have defined. Now let us talk about next equal matrices. What are the equal matrices here? Okay, so let me take if two matrices given here. 10th now, 10th type here, equal matrices. What are the equal matrices? Very important one. Equal matrices. If two matrices are given, more than two matrices, but we are talking about two at the moment. Two matrices. If two matrices that we take here, A is equal to Aij of order m by n I have taken, and B equal to Bij of order, let me take P by Q, are equal if the following conditions are satisfied. The following conditions are satisfied. What are those conditions? Let me talk about. First condition is if m is equal to p. If m is equal to p, number of rows of A is equal to number of rows of B. It means number of rows of A are equal to number of rows of B. Number of rows of A, matrix A, are equal to number of rows of B. Second condition, if n is equal to q, again number of columns, let me write here, this is capital, number of columns of A are equal to number of columns of B. Second condition. Third condition is corresponding elements are equal. The corresponding elements of both the matrices are equal.